of the tangent line to our equation y equals x plus the square root of x at the point 1, 2. And then it says after that, then graph both the curve and the tangent line on your calculator to make sure that it all makes sense. All right, so Andrew, you wrote this problem down. What were your thoughts when you started?
I was like, get some equations.
That limit definition?
Yeah.
Right, and so the answer to that is no. Okay? So when I look at this, and it says find the equation of the tangent line, then immediately what you want to think is, okay, equation of a tangent, or equation of any line, I need a point and a slope. Now our point is given to us, that's the point 1, 2. And if they had only given us an x value, then we can plug that x value into our function up here, and 1 plus root 1 gives us our y value, which is 2. So that gives us our point. And our slope is going to be the derivative of our function up here. So if we call this function instead of y, if we call it fx, then our slope will be f prime evaluated at x equal to 1. Now, one way to find that value is to use that limit definition. An easier way is to say, okay, let's use our derivative rules, calculate f prime of this function, and then plug in x equal to 1. So, since our function is f of x is equal to x plus the square root of x, I want to take the derivative of this, which means the very first thing I want to do is to rewrite that square root. And so I'll write this as f of x is equal to x plus x to the 1/2. All right, so now what I have is two functions that are added together, the x and the x to the 1/2, which means I can take the derivative of each of these terms separately. So our derivative looks like f prime of x is equal to 1, plus our derivative of x to the 1/2 will bring the 1/2 in front, and x will be now raised to the negative 1/2 when I subtract 1 from 1/2. So here's our derivative. So I'm going to be using this. Now, if I was just asked to calculate the derivative, then I'd be done right here. But we actually want to plug an x value into there. So I'm going to rewrite this so it's a little bit more useful to use. F prime of x is equal to 1 plus, now this negative tells me I can put that x in the denominator. And the 1/2 tells me that I'm really taking the square root of x. Are there any questions on how I rewrote that? Okay, so this is our derivative, but we would like to know what the slope of our original function is when x is equal to 1. So we'll plug in 1 for x into our f prime function. So we've got 1 plus 1 over 2 times the square root of 1. And so we've got 1 plus 1/2, which is 3/2. All right, so that gives us our point and our slope. Our slope is 3/2, and we can write down our equation of our tangent line. All right, so the equation of our line I'll use the y minus y1 is equal to slope times x minus x1. And so y minus the y value, which is 2, is equal to 3/2 times x minus the x value, which is 1. And if you're not told anything else about the equation of your tangent line, then we're done right there, and everything is good to go. But if we want to actually type that into the calculator and check to see if this is a legitimate tangent line to this given function, then I would want to solve and write this in y equals mx plus b form. So we've got y minus 2 is equal to 3/2 x minus 3/2. Add 2 to both sides, and we've got y is equal to 3/2 x plus 1/2. Okay, so Andrew, the moral of this story is that unless you are specifically told that you must use the limit definition of a derivative, assume you can use the shortcut methods to find your derivatives. All right, are there any questions about number 27? Key points here are that if we want to find the equation of the tangent line, given to us, and we need a slope. And our slope comes from our derivatives. We need to calculate the derivative, plug in our x value. Okay, and that will give us our slope. Okay, other practice problems.